We're going to look at function composition. These are a couple examples from homework worksheet 4.4. Let's just think about function composition in general. So function composition is when we take a certain function, f of x, and we take another function, g of x, maybe it's 3 plus x, and we use as the input for one of the functions another function itself. Our input to one isn't just a number, it's an actual function. So what we end up getting, if we were to compose, let's find another color. If we were to compose f of g of x, then really what we're doing is we're taking f 2 times something, but that something is actually going to be another function. So we're evaluating the function at another actual expression, another function. That's the input. So if I was to continue to write this and to solve it out, I'd have f of g of x equal to 6 plus 2x. And this would actually be my answer. So let's go ahead and work these 3 pieces. So the first thing we have is f of g of x. Well, this is the inner function. That's what's going to be the input or the substitute in for whatever variable I see for f. So f of g of x, and that's how we're saying it, is I'll take the function f and I'll input g of x for it. So here's my function f, and then I see my variable is x, so x plus 5, and then I'm going to square it. So this is 3x squared, except my x, my input, is actual g. So we'll go ahead and simplify, but I can't just distribute this in, I have to FOIL. So if I FOIL that, I get x squared plus 10x plus 25. Again, I encourage you to get your FOILing skills down well. If we distribute the 3 in, we have 3x squared plus 30x plus 75. So 3x squared plus 30x plus 75. And I encourage you to always write this piece. There we go, there's our answer. So in this case, we have g of f of x. So now f of x is going to be the input to g. So g of f of x is going to be, well, let's start writing g. So that would be x plus 5. Maybe I'll write that up top. But we don't want an x. We want whatever f of x is. So let's put that in. We have 3x squared plus 5, because g is something plus 5, but my something is the function f, and I can't simplify any more than that. So that's where I leave it. I'll rewrite it again. G of f of x is equal to 3x squared plus 5. And the next thing we're going to look at is if we have g of f of negative 2. If we hadn't already calculated g of f of x, which is this here, we can actually just evaluate the inner and then use whatever value we get here for g. So let's look at this 2 ways. Let's look at actually taking this first function and evaluating f of negative 2. So f of negative 2 would be 3 times negative 2 squared, which is 3 times 4, and that's 12. So if we take that output, the output of 12, since that's really what f of 2 is, we can just plug that in. So the first step would be to work the inner function, and then the last step would be to take the output of that inner function and just evaluate it into g. So I get g of 12 equal to 17. So rewriting that, we'd have g of f of negative 2 equal to 17. And we can keep it like that. But the other way we could have fully worked that is saying, well, if I know what g of f of x is, but x is negative, it it was negative 2 when we originally tried to do it. So I could say g of f of negative 2 is actually 3 times negative 2 squared plus 5. So I'm just plugging the negative 2 right into there. So 3 times 4 plus 5, I'm following the order of operations, and that equals 17. So I get the same value. That's really what function composition is, we were saying, is you are evaluating one function and then putting that output into the next one's input. So these are the same kind of idea and concept. The other thing I wanted to go over is that given these two functions, let's compose them and get kind of a different sort of answer. In the previous problems, we got something we had to simplify, and it just gave us another expression. But these, when we simplified, gave us an interesting answer. So if I want to perform f of g of x for this problem, I'm going to take g, this whole thing, and plug it in for the x here. So I have the square root, and let's put this all in red maybe, x minus 2 squared plus 3. So this whole thing's got to go in for here. And then I still have a minus 3. This minus 3 is the same, plus 2. Looks a lot messier than it is. We'll simplify those. And underneath the radical, I'm going to have the square root of x minus 2 squared. We don't have any 3's anymore, plus 2. If I have the square root of something squared, it ends up just being that value underneath. And then plus 2. These cancel. And I'm left with just an x. So f of g of x, when I compose these particular two functions, I just get x. And we'll find that in our next section when we do inverse functions, that these particular functions are inverses of one another, which is why they result in this answer. So let's look at the other g of f of x. So I will be starting with g, and then I'm going to put f in for g. So g of f of x is going to be equal to, let's start writing g. Well, g starts with a parenthesis, and then here's my x. So let's plug whatever this is in. So the square root of x minus 3 plus 2. So that's this piece. And I still have this minus 2 and the squared plus 3. So this square root of x minus 3 plus 2 is filling in right for this spot. So I still have everything else in the equation. If we go ahead and simplify it, these cancel. So I'm left with the square root of x minus 3 squared plus 3. When I have the square root of something squared, I end up with just the radicand underneath. The 3's cancel, and I'm left with x. So g of f of x is equal to x in this case.